The scene opens in absolute darkness, the silent expanse beyond Neptune. Out there, where sunlight fades to memory, a ghostly visitor enters our solar system. It is designated 3I Atlas, only the third confirmed interstellar object ever detected by humankind. But from the moment its light touched our telescopes, something felt wrong. Unlike Oumuamua's strange acceleration, unlike Borisov's icy perfection, this new traveler carries a signature never seen before, a metallic breath of nickel, glowing faintly in the ultraviolet, a whisper of forged matter adrift among the stars. Astronomers expected dust, rock, silence. Instead, they found order, spectral lines too clean, too deliberate, ratios of nickel and iron that mimic alloys, not minerals. From the European Southern Observatory to the James Webb Space Telescope, the data converged on one impossible truth. The light from 3I Atlas was not natural, it was structured. How does a body born of chaos emit with such precision? How does metal, drifting cold and ancient through interstellar night, sustain a glow as if remembering the furnace that made it? The universe is ruled by chemistry and decay, yet this object sings with design. It defies entropy. It defies chance. It behaves as though it were built. Perhaps it is nothing more than coincidence and the perfect accident of cosmic physics. Or perhaps, hidden in that faint metallic whisper is evidence of a will older than our own. A question hangs in the darkness between stars. In the breathless stillness of early July 2025, the Atlas telescope kept its silent vigil in the Chilean desert. Its mirrors faced a canopy of cold stars repeating the ancient ritual of scanning, measuring, and waiting. On one ordinary night, a streak appeared on the digital horizon, so faint it could have been a sensor's tremor or a fragment of static drifting across the data feed. Yet as the automated tracking program processed the frame, it flagged an irregular motion, a faint point of light sliding across the firmament in a path that disobeyed every prediction of known orbital mechanics. The algorithms ran again, recalibrating, rejecting cosmic rays, noise, and aircraft trails. Still the same anomaly persisted, a visitor tracing a path unbound by the sun's gravity. The observatory servers logged the coordinates and the alert rippled outward, moving through networks of astronomers across continents. It was just after midnight when a researcher at the University of Hawaii noticed the impossible. The trajectory curve was hyperbolic, not closed, not elliptical, but open. It would come and go once, never to return. Across the Pacific, as dawn approached, messages poured through internal communication channels. Quiet, clipped lines of text that carried the weight of wonder. The team initiated confirmation protocols, comparing the new data with archived exposures. In images from late June, the same spectral trace could be found, moving just as steadily, showing that this was not a transient flare or noise artifact. What they had found was real, a celestial body cutting across the solar system at an extraordinary velocity, faster than any asteroid native to our star's domain. Within hours, observatories across the world swung their eyes to the coordinates. Gemini North on Mauna Kea, the Canada-France-Hawaii telescope, and La Silla in Chile each reported the same thing. A dim traveler, magnitude 18, moving with deliberate purpose against the tapestry of distant constellations. Teams fed the data into orbital solution programs. Each model returned the same verdict. This object was not gravitationally bound. It had entered from the direction of Sagittarius, speeding through our planetary neighborhood like a message sent from another sun. By the next night, the Minor Planet Center received enough observational points to assign a designation: 3I Atlas, the third interstellar object ever confirmed. The 3I placed it in a lineage with two enigmas before it: Oumuamua in 2017 and Borisov in 2019. Objects that had already rewritten textbooks and kindled countless debates. Yet even in this illustrious company, 3I Atlas was different. Its light signature hinted at a metallic undertone. Its reflective surface gleamed colder, denser, harder than expected for a typical comet. Telescopes worldwide gathered light, sifting it through spectrographs to decode its chemistry. What they found would later spark controversy, a suggestion of nickel emissions that defied simple categorization. But in this first moment of contact, the focus was simpler: to measure, to watch, to witness. In the control rooms, the tension was palpable. Monitors displayed numbers that seemed to break the quiet laws that govern the sky. The orbital eccentricity crept past 1, mathematically a sign that the visitor was forever unbound. If the sun were a campfire in the dark, this was a spark blown in from another blaze entirely. As the Earth turned, astronomers in Europe joined the pursuit. The European Southern Observatory and ESA's network of optical sensors traced the faint arc of motion hour by hour. Data streamed continuously: right ascension, declination, velocity vectors. The object's path intersected the plane of the solar system at a sharp angle, like a skipping stone slicing through water. The calculated speed, nearly 60 kilometers per second, meant it would pass close enough to the sun to ignite a brief coma before vanishing back into the void. For a moment, the global astronomy community became a single nervous heartbeat. The discovery came at a time when humanity's instruments were more powerful than ever, yet still limited by distance and light. Here was a fragment from beyond the heliosphere, arriving uninvited, untouched by solar wind for untold ages. The idea was intoxicating. A messenger from another star system had brushed past us close enough to measure, too far to reach. The object itself remained silent, indifferent to the excitement it had stirred. It drifted through space as it always had, its nucleus perhaps frozen for millions of years, its surface scoured by interstellar dust, its story written in elements older than our planet. Through spectrometric data, scientists glimpsed shades of iron and nickel glinting beneath the reflective frost. It was not simply a dirty snowball like most comets. It bore the signs of deep metallic structure, something born in the heavy element forges of distant suns. While confirmation messages circulated among NASA, ESA, and JWST, the public announcement was delayed. Precision mattered more than spectacle. Teams rechecked parallax, recalculated the orbital solution using extended baselines, and validated every frame. On July 2nd, the final verification came through. The trajectory was conclusively interstellar. The announcement went out quietly, with the measured humility that great science demands. In the following nights, newsrooms began to take notice. The world learned of an object traveling between the stars, passing through our solar system like a lone wanderer. To most people, it was a distant curiosity, a small dot in space invisible to the naked eye. But to the scientists who had traced its arc, it was something closer to poetry, evidence that the galaxy is not empty, that the space between stars is alive with debris, fragments, and possibly stories. At observatories from Arizona to South Africa, Researchers studied its light curve. It brightened subtly as it neared the sun, suggesting active outgassing. But the flare was inconsistent, erratic. Unlike typical comets, which obey predictable cycles of sublimation, 3I Atlas seemed restrained, as if conserving its energy. Even these slight changes told a story of structure, density, and perhaps mystery. The mathematics of motion confirmed what intuition already felt. This object had traveled for millions, perhaps billions, of years across the galactic sea before crossing our path. Somewhere, light years away, it had been expelled from its home system, perhaps through gravitational slingshot, perhaps through stellar chaos. For ages it had drifted in darkness, untouched, unseen, until one moment of cosmic coincidence brought it within range of human vision. As its coordinates spread through academic channels, telescopes cued exposure sequences like orchestras tuning for a once-in-a-lifetime performance. Each photon caught from 3I Atlas carried a trace of its journey, a fingerprint from another world. The data poured in, filling terabytes of storage. Positional updates, compositional hints, brightness fluctuations, color indices. The numbers sang quietly of distance, of exile, of returnless travel. Astronomers knew they would have only weeks before the object dimmed beyond reach. There was no time for hesitation. Observing campaigns coordinated globally, sharing protocols, ensuring that every wavelength, from infrared to ultraviolet, was captured. Observers spoke of sleepless nights, of pacing between monitors, of feeling as though they were conversing with the galaxy itself. And still, amid all the feverish measurement, an almost spiritual quiet held. To look at something born around another sun, to analyze its chemistry, its orbit, its gleam, was to touch the edge of the unknown. The numbers on screen were not abstractions. They were messages from the Milky Way's wider family, whispering across the void. When the data confirmed its outbound trajectory, when the final ephemerides proved it would slip away forever, a solemn understanding settled in. Humanity had again glimpsed the broader ocean in which it drifts. These interstellar visitors are brief, indifferent, and profoundly humbling reminders that we are not stationary in the cosmos, but afloat in a constant exchange of matter and mystery. By the time dawn touched the observatories, Atlas was already receding, its light dimming as it left the inner solar system, carrying with it questions no spectrum could yet answer. Yet its brief passage had already expanded the boundaries of human curiosity. Under the quiet hum of data servers, someone whispered what everyone else felt but would never publish. That for a fleeting moment, Earth had been noticed, not by an intelligence, but by existence itself. And as the signal faded into the noise of a billion stars, the night resumed its patient rhythm. The object moved on unchanged, but those who had seen its trace, those who had calculated its speed and distance, knew they would never look at the darkness the same way again. For out there, beyond the sun's reach, another traveler was surely waiting to be found. Already on its way, crossing the void, a silent echo of creation still glowing with its first light. The first data from 3I Atlas had been exhilarating, but it was what came next that unsettled even the most disciplined scientists. As the comet drifted inward toward the sun, instruments across Earth and in orbit began gathering its light. The readings poured in: spectra, intensity curves, polarization data, the fingerprints of the elements composing this traveler from beyond. When the first composite spectrum appeared on the monitors at the European Southern Observatory, it looked almost familiar. There were faint emissions typical of cometary activity, traces of dust scattering sunlight, molecular carbon, maybe some water vapor. But beneath those expected patterns lay something else. Sharp metallic lines that glowed faintly at the edges of the ultraviolet. They corresponded to nickel and iron, yet the ratios were wrong. The balance of these metals defied the known chemistry of comets and asteroids. At first, the anomaly seemed like a calibration error. The telescope's spectrograph was rechecked, then rechecked again. It wasn't the machine, it was the object. The nickel emissions were not only present, they were unusually strong, even as the object remained too distant and cold for such metals to sublimate. According to every physical model of cometary behavior, this should not have been possible. At NASA's Goddard Space Flight Center, a small team began analyzing the spectra independently. Their results matched. The nickel-to-iron ratio was higher than in any known natural body. Even stranger, the emission temperature appeared to be stable, as though the metal were being excited not by sunlight, but by some intrinsic process. The data were relayed to the James Webb Space Telescope's scheduling team. Within days, JWST trained its infrared eye toward the faint glint of 3I Atlas, the telescope's sensors captured the spectral heat signature. Faint but consistent infrared glow between 10 and 15 microns. For an object at such a distance, the thermal energy was inexplicable. The numbers implied that the nickel-rich surface retained heat longer than expected, resisting the cold of interstellar space like an engineered alloy. That single observation sent ripples through every major observatory. Nickel is common enough in the universe, born in supernovae scattered through planetary cores, but it doesn't glow in isolation, not like this. For it to radiate so persistently, something within the material structure had to be sustaining the emission. When scientists overlaid the JWST spectra with laboratory data from known nickel-iron compounds, the match was incomplete, yet hauntingly close to certain engineered materials used in high-performance aerospace alloys. The emissivity curve of 3I Atlas didn't resemble that of a natural meteorite. It resembled something tuned. At first, the speculation was cautious. Perhaps the interstellar traveler had formed near a supernova remnant, where atomic pressures and heat could create exotic metallic bonding. Or perhaps it had passed through regions of intense magnetic fields that restructured its lattice. These were testable ideas, comforting in their adherence to physics. But the longer the data were examined, the less comfort they provided. In late July, ground-based optical telescopes recorded a new anomaly, short bursts of reflected light that repeated every 8 hours. The pattern was rhythmic, the result, astronomers believed, of rotation. Yet each peak of brightness was accompanied by a subtle change in the metallic spectrum, as though different regions of the object had distinct compositions. It was as if the surface were segmented, panels of varying reflectivity turning toward the sun. No natural comet had ever exhibited such structured modulation. Within the quiet conference calls of NASA, ESA, and JAXA researchers, a word began to circulate hesitantly: unnatural. Not artificial, not yet, but unnatural in the sense that it didn't belong to any known category of mineralogical behavior. In Zurich, a materials scientist named Dr. Kappel simulated how nickel grains could form in microgravity. The results were unambiguous. Random crystallization always produced disordered spectra. The structured emission seen from 3I Atlas required coherence. Atomic alignment at scales impossible, without either sustained magnetic influence or deliberate engineering. Yet no such magnetic field existed in the path of its origin. Back at Mauna Kea, the Gemini North Observatory recorded new high-resolution imagery. The nucleus glinted faintly in polarized light, a telltale indicator of metallic reflection. Even accounting for dust scattering, the polarization was too clean, too consistent. It looked like the sheen of polished metal, not the dull reflectance of rock or ice. Every discovery brought more contradiction. The surface appeared metallic, yet it also outgassed faintly like a comet. Its rotation was stable, yet its brightness fluctuated in precisely timed intervals. Its thermal signature defied distance. The object was both comet and not comet, metal and not mineral, passive and yet seemingly active. Scientists struggled to contain the narrative. They feared that public imagination would leap ahead of the data, that words like probe, craft, or artifact would overwhelm the fragile truth still forming in the numbers. And yet, even in the most cautious papers, the unease was visible between the lines. At the European Southern Observatory, a researcher quietly remarked that the nickel emissions resembled those found in heat-dissipating alloys, materials designed to manage temperature in spacecraft. The comment was not included in the official summary. Still, the thought lingered in everyone's mind. What kind of natural body cools itself with such precision? Over the weeks that followed, the measurements grew more refined. Nickel and iron were not the only metallic traces detected. Faint lines corresponding to cobalt and chromium began to appear, the same elements that form high-stability alloys on Earth. The ratios were not perfect, but they were close enough to unsettle anyone who understood metallurgy. By early August, 3 Atlas was drawing near its perihelion, its closest approach to the Sun. Observatories watched for the moment when solar heat would ignite its coma fully. Instead, the emissions barely changed. The nickel lines persisted unwavering, as though the metal resisted vaporization. It became clear that 3I Atlas was not behaving like a typical visitor. Oumuamua had accelerated mysteriously as it left the Sun, and Borisov had dissolved spectacularly in a natural cometary outburst. But Atlas, silent and metallic, glowed with a steadiness that felt deliberate, like a machine maintaining equilibrium. At a symposium in August, one astronomer summarized it in a single chilling sentence. "It behaves as though it knows how to stay alive." No one dared repeat it in official publications, but the remark spread quietly through the community. Could a natural object exhibit adaptive thermal behavior? Could magnetic resonance or internal radioactivity explain the stability? Theories emerged, each more desperate than the last, yet none could fully describe the phenomenon. Behind closed doors, some researchers began reanalyzing old data from Oumuamua and Borisov, searching for missed metallic signatures. They found none. Whatever 3I Atlas was, it stood alone. When Hubble trained its instruments for a final optical pass in early September, the glow remained steady, a cool, unwavering metallic pulse amid the stars. Its spectrum told the story of an alloy that should not exist, born of processes beyond the catalog of known astrophysics. As the object moved past the Sun and began its slow retreat toward interstellar space, the scientists who had tracked it for months watched its signal fade with mixed awe and fear. It was leaving behind more questions than answers. Perhaps it was nothing more than coincidence, the accidental byproduct of cosmic extremes, a sculpture carved by radiation and time. but in the quiet halls of observatories, where the lights burned low and the data screen still shimmered with the afterglow of its passing, another thought took hold. If nature could create something this precise, this metallic, this enduring, then what else might it be capable of unless in the dark reaches between the stars? And if it wasn't nature, then what hand had shaped the metal that glowed where no life was supposed to leave a mark? Nickel is an unassuming element, often overlooked amid the dazzling chemistry of the stars. Yet within its atomic structure lies a story that reaches back to the very birth of the universe. A story of fire, collapse, and time. To understand 3I Atlas, scientists had to first understand this metal that, in the cold vacuum of interstellar space, somehow chose to shine. Every atom of nickel is a relic of destruction. It is forged in the dying breath of massive stars, in the catastrophic implosions known as supernovae. When a star many times larger than our sun exhausts its fuel, gravity overwhelms its core, crushing matter until it detonates outward in an apocalyptic bloom of light and energy. In those moments, under temperatures exceeding billions of degrees, lighter elements fuse into heavier ones. Hydrogen becomes helium. Helium becomes iron. And just beyond iron's stability lies nickel, born in chaos, stabilized in cooling, scattered across the galaxy as dust. For billions of years, these nickel grains drift through the interstellar medium, eventually finding their way into new systems, new planets, and sometimes the metallic veins of asteroids. On Earth, nickel is commonplace, alloyed in our coins, our machines, our blood. But in the wider cosmos, nickel holds a deeper significance. It is the fingerprint of stellar death and renewal, a reminder that all complex materials trace their lineage to violent origins. Yet what 3I Atlas revealed was not the nickel of ordinary worlds. It was pure, radiant, and active, its emissions behaving as though the metal itself retained memory of the furnace that made it. No comet from within the solar system has ever displayed such behavior. Nickel in our comets hides beneath dust, mixed with silicates and frozen carbon compounds. Only at extreme temperatures, thousands of degrees, does it begin to glow. But Atlas, still distant and frigid, radiated nickel's spectral lines with serene defiance of thermodynamic law. Scientists began retracing the cosmic pathways where such metal could have formed. They considered core collapse supernovae, the crucibles that produce nickel-56, a radioactive isotope that decays into cobalt and then into stable iron, powering the afterglow of a supernova's light for months. Perhaps 3I Atlas had been born in such an event, its crust frozen mid-decay, locking the isotope's energy in a metastable state. But the timing didn't fit. Nickel-56 decays quickly when within weeks, not eons. Whatever gleamed inside 3I Atlas was no longer radioactive. It was something else entirely. Attention turned to more exotic origins. Could the object have formed near a magnetar, one of the universe's most extreme stars? A neutron core spinning at hundreds of rotations per second, wrapped in magnetic fields trillions of times stronger than Earth's? Such environments could realign atomic lattices, embedding energy in structure rather than radiation. The idea was daring but elegant. Perhaps Atlas carried the crystalline scars of a magnetar's birth. In laboratories, material scientists simulated these conditions as best they could. They exposed nickel-iron alloys to powerful magnetic fields, to plasma streams, to cycles of freeze and thaw mimicking the extremes of interstellar travel. The results were illuminating but incomplete. No natural process they could reproduce generated the coherent spectral lines seen in Atlas. The alloy from the comet was more ordered, more symmetrical, as if refined over millennia. To grasp its strangeness, scientists turned their gaze backward to our own planetary history. In the early days of Earth, molten nickel flowed within the planet's core, creating the magnetic field that protects life from solar wind. It is this same metal, deep and ancient, that silently sustains the compass of every bird, every migration, every navigation. Nickel is both the hidden heart of our planet and the echo of dead stars. The paradox was cruelly poetic. Here, in a fragment drifting from another system, nickel once again appeared as the engine of mystery, not buried, not inert, but radiant. The question grew sharper. How could an element known for its durability become the source of light in a comet so cold? Some proposed that the metal could act as a photothermal capacitor, a structure capable of storing solar energy and releasing it slowly, maintaining a glow even as temperatures fell. Others suggested that microscopic lattice imperfections, introduced by cosmic radiation, could trap electrons in metastable states. When released, these electrons might emit the observed spectral lines. It was a hypothesis that bordered on the edge of known physics, and yet, in the vastness of the universe, the improbable is merely the undiscovered. For every hypothesis raised, another question emerged. Why were the emission ratios so consistent? Why did the spectral intensity remain steady, even as Atlas rotated and receded? The symmetry of the data implied uniform distribution, as though the object's metallic structure were homogeneous, pure to its core. Nature, in all her creative chaos, rarely crafts such perfection. Philosophers of science began to weigh in, noting that the line between natural precision and design is vanishingly thin. The shape of a snowflake, the pattern of a seashell, the geometry of a galaxy, all appear deliberate when observed without context. Perhaps Atlas was simply another expression of cosmic geometry, a sculpture of chance. But deep in the spectra, hidden within the numeric symphony of photons, something refused to align with coincidence. The proportion of nickel to iron was skewed, not random, not chaotic, but following a ratio eerily close to engineered alloys developed for thermal resistance. This was not proof of intent, but it was a whisper, one that scientists couldn't ignore. Even Einstein once remarked that the most incomprehensible thing about the universe is that it is comprehensible, that its patterns, though vast and ancient, can be parsed by human thought. And yet, as Atlas defied every model, comprehension slipped further away. It was as though the object stood at the intersection of nature and purpose, inviting humanity to question what divides the two. As weeks passed, more observatories joined the campaign. Polarimetric readings showed an unusual reflectivity, almost mirror-like, suggesting smooth metallic grains rather than the jagged dust typical of comets. The temperature gradient across its surface remained even, no hot spots, no violent vents, only calm, continuous radiance. This calmness unsettled the scientists most of all. Nature is noisy, imperfect, and restless. But 3I Atlas was silent and symmetrical, its light steady as though held in equilibrium. The object behaved less like a piece of rock and more like a fragment of order, a geometry maintained across the void. To some, it became an emblem of cosmic humility. Humanity had once believed that the stars were fixed and eternal. Then it learned they live and die. It believed that matter was inert. Now it glowed with the memory of impossible heat. 3 Atlas was another revelation, a small, indifferent reminder that our knowledge is young, that the periodic table itself may still hold secrets not of chemistry, but of design woven into physics. In the quiet of data labs around the world, teams replayed the spectra, watching the metallic lines rise and fall like heartbeats from an ancient machine. It was just light, data, nothing more. Yet it carried the pulse of something immense. The echo of stars long dead, perhaps the residue of an intelligence long gone, or perhaps just the universe speaking in its native language, the language of pattern. By September, as the object began to move away from the sun, its nickel signature faded but never vanished. Even as it cooled, the metallic glow persisted faintly, refusing to die completely. It was as if the metal itself carried a kind of memory, a resilience that transcended temperature, time, and distance. In that fading light, humanity was offered a reflection of its own persistence. For what is science but our species' attempt to hold on to understanding, to make sense of the fleeting brightness before it disappears? And as 3I Atlas continued outward, beyond the reach of our instruments, beyond the certainty of our equations, it left behind not just data, but a quiet question. If nickel, the element born from stellar death, can still shine in the darkness between worlds, what else might endure out there, waiting to be seen, waiting to remind us that even in silence, the universe is not asleep, but speaking softly through the metals of creation? By the second week of September 2025, 3I Atlas was already well past its perihelion, the closest point in its brush with the sun. Most comets flare spectacularly when they near that fiery intersection, shedding trails of vapor and light as if announcing their arrival. But Atlas had remained composed, distant, deliberate. Its coma shimmered faintly, its nickel lines still glowed in defiance of reason, and yet it showed none of the chaos that should have accompanied such proximity. It was then, in the calm after the brightest phase, that something new began to whisper through the instruments. At first, it was just background noise, a low-frequency irregularity detected by a small radio array in South Africa. It appeared during a calibration run, a faint pulse repeating every 8 hours, almost imperceptible. The technician who logged it assumed interference, another case of terrestrial contamination, perhaps a satellite or distant relay. But when the next observation came, the signal was there again, perfectly timed with 3I Atlas's rotation period. Radio telescopes across the globe began cross-checking the anomaly. The pattern held, a sequence of narrow-band bursts spaced evenly over hours, fluctuating slightly with the object's changing distance from the sun. The signal was faint, consistent and synchronized with the comet's spin axis. It wasn't broadcasting information. It was modulation, a thermal rhythm, a whisper of energy that mirrored its metallic heartbeat. The scientists resisted excitement. Instruments could lie. Interference could deceive. Yet, as the data piled up from observatories in Spain, Australia, and Chile, the coincidence became mathematically improbable. The radio bursts weren't random noise. They were structured. NASA's Deep Space Network was brought in for verification. Using its vast antennas in California and Madrid, the team tracked Atlas's position for a continuous 48-hour window. The signal repeated with exquisite precision, each pulse separated by exactly 7.9 hours. When the comet turned, the emission faded, only to return with the same spectral tone as it rotated back into alignment. It was as if one side of the object, one metallic face, reflected not only sunlight but something deeper, something coherent. The data were passed to the European Space Agency's radio astronomy group, who analyzed the frequency drift. The pulses showed a Doppler shift consistent with the object's motion, meaning the source wasn't external. The energy was coming from 3I Atlas itself. In the quiet of late-night labs, the thought began to emerge, not spoken but felt. Could the metal itself be oscillating? Could its atomic lattice, under stress from solar radiation, produce electromagnetic waves? Some materials, especially crystalline alloys, can act as resonant systems, converting heat or mechanical stress into electromagnetic vibration. But for that to happen naturally, the structure must be flawless, the geometry precise. Nature rarely crafts perfection, and yet here it was, humming softly across the void. The first official report labeled the phenomenon rotationally modulated thermal resonance. It was an elegant phrase for something no one understood. Theories multiplied. Perhaps cosmic rays had induced surface charge differentials, causing periodic discharges. Perhaps buried magnetic domains were reorienting as it spun, releasing energy in predictable cycles. Yet each theory failed in one regard: persistence. The signal didn't weaken. It didn't fade. Even as the object moved farther from the sun, its rhythm continued, calm and unwavering. Then came a revelation from the Meerkat Array in South Africa. High-resolution mapping showed that the emissions weren't uniform. They originated from localized regions, symmetrical about the comet's equator. These regions radiated slightly more strongly at frequencies correlated with nickel's magnetic resonance lines. In essence, 3I Atlas was ringing like a metallic bell, a celestial oscillator in the vacuum of interstellar space. For days, researchers tried to smother their wonder in equations. They searched for natural analogs. Could such patterns arise from crystalline stress release, from microfractures or magnetothermal coupling? But no terrestrial or cosmic example matched this precision. The energy output was tiny, far too weak to be technological, but its discipline unsettled everyone who saw the data. At the Lunar Radio Observatory, engineers filtered the signal to extract harmonics. To their surprise, they found faint overtones, harmonic echoes that followed mathematical ratios familiar from acoustic physics. In sound, such intervals form music. In energy, they form structure. The universe seemed to be playing a note, repeating endlessly through an object born between stars. Publicly, no one mentioned this poetic detail. But privately, the term spread, the nickel song. While the global networks focused on the radio domain, optical instruments continued to track the comet's brightness. Photometric analysis revealed subtle glints that coincided with each radio pulse. Light and energy were synchronized. Something was coordinating them. Then a faint radar echo returned from an experiment conducted by the Goldstone Deep Space Communications Complex. The signal bounced off the comet's surface and returned slightly stronger than expected, as though parts of the object were unnaturally smooth, reflecting more efficiently than ice or rock. When processed, the radar pattern hinted at geometric complexity. Not a perfect sphere, not a random shard, but a body with flat planes, perhaps facets. Nature does carve symmetry, but rarely in planes. The notion was intoxicating and dangerous. Scientists had learned after Oumuamua the peril of imagination overtaking data, but still, The parallels were impossible to ignore. A metallic object unbound by the sun rotating with precision, emitting faint radio modulations. It was as if the universe had dropped another puzzle into human hands and whispered, "Listen carefully this time." At the International Astronomical Union's emergency teleconference, voices argued across continents. Some insisted that 3I Atlas was a naturally magnetic comet, its emissions caused by ferromagnetic relaxation. Others hinted that the observed coherence was beyond any known geological process. The debate spiraled late into the night. No consensus emerged, only an uncomfortable silence. When the minutes of that meeting were archived, one unrecorded remark lingered in memory. A senior physicist, staring at the unbroken chain of pulses, muttered, "If this is random, it's the most disciplined randomness the universe has ever performed." By late September, the signal began to weaken as Atlas receded beyond the range of most ground instruments. Yet its rhythm persisted in the noise, faint but still measurable. Radio astronomers described it as a heartbeat fading beyond hearing distance. Even as the object's brightness diminished, the metallic pulse continued its cosmic tempo. Perhaps forever. Perhaps until it met another star. In the aftermath, the data were archived in silence. Papers were drafted, language softened, conclusions left open. Periodic thermal resonance, the report said. Likely magnetic in nature. But those who had watched the faint pulse across their screens, those who had measured its unwavering precision, carried a different conviction, not of aliens or artifice, but of something grander. That matter itself might remember creation, that the metals forged in ancient fire still hum the frequencies of their birth. For humanity, the discovery was humbling. Every star, every rock, every atom might sing, but only those who listen carefully enough will hear the music hidden in the noise. And somewhere beyond the reach of our instruments, Atlas continued on its path, a silent bell drifting between suns, its nickel skin still vibrating with the residue of forces older than life. Older than meaning, a signal perhaps not sent one but simply existing, a cosmic hum waiting for ears that can finally understand. When the full dataset from 3I Atlas reached the world's research archives, it was as though a tremor passed silently through the scientific establishment. No explosion, no drama, just a widening of eyes in quiet laboratories, a stillness that often precedes revelation. The numbers did not align with the universe as it was known. For the first time in years, astrophysicists whispered the word impossible without irony. The nickel emissions had already challenged chemistry. The rhythmic radio pulses now unsettled physics. Together they created a tapestry too coherent to dismiss. The data was checked, corrected, scrubbed for error, yet every repetition produced the same result. A comet-like object from interstellar space, metallic and reflective, emitting spectral lines of nickel at temperatures too low for nickel to glow, and producing periodic radio harmonics synchronized with rotation. If this were a lab experiment, the conclusion would have been clear. It was designed. But in the scale of the cosmos, design is a word used with great caution. The first reaction was restraint. Scientific culture demanded skepticism, demanded the stripping of wonder down to math and noise. Researchers at NASA's Jet Propulsion Laboratory issued a conservative bulletin. No evidence of artificial origin is supported at this time. They emphasized magnetic interactions, thermal resonances, charge redistribution. Safe explanations that could occupy public understanding, while the deeper investigation continued behind closed doors. Yet outside those walls, speculation spread like wildfire. News outlets drew parallels with Oumuamua, that earlier visitor whose sudden acceleration had never been fully explained. Documentaries revived the ghost of that first interstellar mystery, asking if 3I Atlas was part of a pattern, a second act in a cosmic story unfolding over decades. But within the observatories and data centers, the tone was less sensational and more haunted. For those staring into the spectra, the feeling wasn't excitement. It was confusion, and a quiet fear of what the data implied. When the James Webb Space Telescope released its calibrated readings, the scientific community faced its next shock. The surface of Atlas reflected light in a wavelength curve consistent with a metallic lattice. But not just any metal. The pattern of reflection, subtle and complex, resembled engineered alloys designed for thermal equilibrium. The emission intensity plateaued, remaining stable even as the object's distance and solar radiation changed. It was as though 3I Atlas possessed its own thermal logic, regulating heat like a self-correcting machine. No known natural body exhibited such stability. Comets surge in brightness near the sun, then fade. Asteroids warm and cool unevenly. Atlas, however, maintained near-constant thermal output across days, weeks, and thousands of kilometers. It neither flared nor dimmed. It simply endured. The more data accumulated, the harder it became to hide the implications. At a closed colloquium in Geneva, hosted by the International Astronomical Union, senior scientists debated in whispers. On one side were the pragmatists, those who insisted that extraordinary data demanded extraordinary caution. On the other were the visionaries, younger astronomers and theoreticians unafraid to suggest that perhaps for the first time, humanity had intercepted a relic not born of chance. The argument was fierce. One side invoked Occam's razor, warning against conspiracy of meaning. The other invoked the limits of probability, pointing out that random processes rarely produce resonance and symmetry simultaneously. Between them, the truth hung like a pendulum. Then came a discovery that deepened the rift. A reanalysis of the rotational light curves revealed micro-variations, tiny, precise deviations repeating at intervals too clean to be geological. The shape of the curve suggested structure, flat surfaces alternating with convex ones. Nature produces roughness, erosion, and chaos. This was geometry. In one paper, later withdrawn, a researcher from the Max Planck Institute dared to write, "The periodic symmetry observed in 3I Atlas's reflectance suggests modularity rather than randomness." Modularity, the language of design. When the paper was retracted, it was replaced with a carefully neutral phrase, anisotropic surface composition. The truth hadn't changed. Only the words. Meanwhile, the public fascination grew. Social media, the great echo chamber of awe and panic, exploded with theories. Some saw a probe. Others, a fragment of cosmic industry. Others still, a simple comet draped in exaggeration. Scientists braced for the same wave of misinterpretation that had followed Oumuamua. But this time, even the most skeptical minds hesitated. Because even if one stripped away the sensational, the facts alone were staggering. A body from another system, metallic and geometrically reflective, unbound by gravity, emitting steady nickel lines, producing rhythmic radio modulations, maintaining equilibrium in heat and spin. If nature could do this, then nature had become an engineer. As the data reached wider scientific circles, institutions scrambled to respond. ESA convened a cross-disciplinary task force. NASA organized a review board of astrophysicists, material scientists, and exobiologists. Papers flooded arXiv, each proposing a new explanation. Quantum magnetic resonance, cryogenic phase transition, plasma polarization. Each sought to anchor the phenomenon within the known laws of physics. But every model fractured on the same reef: coherence. The emission remained too consistent, the signal too stable, the metal too pure. And then came the emotional breaking point. At the Kavli Institute, an astrophysicist named Elena Marovich spent 3 nights reviewing time series data from the JWST spectrometer. When she cross-correlated the spectral fluctuations with the rotational velocity, she found something subtle but profound. The nickel emissions weren't merely glowing. They were pulsing, slightly out of phase with rotation, as if following an internal timing unrelated to sunlight or temperature. When she presented the result, her colleagues went silent. "If this pattern is real," one said softly, "then something inside the object is controlling it." No one used the word alive. No one dared to suggest machine. Yet both ideas hovered in the unspoken air like gravitational ghosts. The story leaked. Not the data, but the mood. The sense of unease spreading through the scientific community. Soon, think pieces and op-eds appeared. What if the universe itself is building machines? Are we mistaking complexity for intent? Humanity once again was staring into the mirror of the unknown, and the reflection was discomfort. The scientific response outwardly remained disciplined. Journals published careful disclaimers, while conferences doubled down on probabilistic humility. But privately, something had shifted. The universe had always been vast, but now it seemed intelligent. Not because it thought, but because it behaved as though it could. A few daring minds proposed a compromise. That 3I atlas was not engineered but emergent. Perhaps there are conditions, somewhere in the galaxy, where matter self-organizes into stability so refined it mimics intention. Maybe evolution isn't limited to biology. Maybe metals, given time and energy, can evolve patterns that persist. It was a heretical thought, yet one that soothed the discomfort. If the cosmos could produce complexity on its own, humanity was still alone, but surrounded by matter capable of poetry. As the year waned and the object retreated from solar influence, the fervor began to fade. 3I Atlas became a data set, a line in astrophysical history, its pulse quieted in our instruments, though never fully in our imaginations. In retrospect, the shockwave of discovery was not about aliens or technology or proof. It was about perspective. For centuries, science had been a tool of order, a way to tame the unknown. But here, before a single fragment of interstellar metal, order trembled in every observatory, every university, every whispered late-night meeting. One realization began to take root. The universe was no longer a stage of inert matter. It was a dialogue, and this time it had spoken first. As 3I Atlas slipped into the black between stars, its signal fading into the universal noise, humanity was left with a paradox both terrifying and beautiful. That certainty is fragile, that knowledge is motion, and that sometimes, in the heart of mystery, science rediscovers its oldest companion, wonder. When 3I Atlas began its long departure from the sun, the observatories could no longer keep pace. Its signal weakened. Its metallic gleam faded into the background of infinity. But the questions it left behind were far from dimming. Instead, they gathered, condensed, into a new pursuit. If the universe had given humanity a mystery forged in metal, then the only way forward was to rebuild that metal here on Earth. It began quietly. In the fall of 2025, small teams in Zurich, Pasadena, Tokyo, and Geneva received packets of spectral data, atomic ratios, emission temperatures, lattice estimates. No fragment of the interstellar traveler existed to examine, only light. Yet within that light lay the blueprints of the alloy that had defied physics. At CERN, the first experiments took place inside the material sciences wing. Using particle bombardment, scientists recreated conditions of extreme radiation exposure. Iron-nickel composites were cooled under intense magnetic fields, frozen rapidly to mimic the interstellar chill. For days, the chambers hummed with the sound of plasma arcs and magnetic coils. When the samples were tested, some displayed traces of the spectral properties seen in Atlas, but not the stability. Their emissions flickered and died within minutes. Nature, it seemed, had forged a perfection that technology could not yet match. Across the Atlantic, at NASA's Ames Research Center, the team of Dr. Nadia Rains took a different approach. Rather than simulate a single event, they attempted to replicate time itself. Billions of years of cosmic exposure, condensed into weeks. They subjected microgram samples of nickel-iron alloy to high-energy particle accelerations, to thermal, cycling across hundreds of degrees to bombardments of ultraviolet light. Slowly, the material began to change. Under the microscope, its crystal lattice showed signs of self-ordering, boundaries aligning into hexagonal symmetry. When cooled to interstellar temperatures, the alloy retained heat longer than expected, exactly as 3I Atlas had. The data were astonishing. Something within the metal had reorganized itself into a state of perpetual equilibrium. Dr. Rains stared at the graphs in silence. "It's almost as if," she murmured, "the material wants to remember warmth." The experiment spread. ESA's laboratories in Nordwijk began analyzing phase transitions, while Japan's Riken Institute experimented with vibrational harmonics, seeking to reproduce the subtle radio resonance. Their results were mixed. Some alloys exhibited faint electromagnetic oscillations, spontaneous and rhythmic, as though mimicking the comet's faint hum. But no one could explain why. At first, the term autonomous resonance was used, the idea that under specific, crystalline conditions matter could sustain low-energy oscillations without external input. It was not life nor technology, but something in between, a physics not yet named. In Zurich, a young theoretical physicist, Ilya Baranov, proposed a radical idea, that the alloy's behavior was not mechanical at all, but quantum. Perhaps its lattice trapped pockets of coherent electron states, minute quantum memories that allowed energy to cycle internally without dissipation. To support his claim, he cited the persistent emissions from Atlas, a body that seemed to operate on an infinite energy echo. The proposal was bold, bordering on metaphysics, yet it gained traction. The laboratories began to treat the interstellar alloy not as a passive material, but as an active structure, something that participated in its environment. By November, the collaboration reached a new phase: artificial synthesis. Using high-precision molecular beam epitaxy, a process that builds materials atom by atom, a prototype alloy was created, designed to mimic the ratios measured from Atlas's nickel lines. The slab was no larger than a fingernail, but its interior symmetry was nearly perfect. When cooled to 240 degrees C and exposed to a modulated magnetic field, it began to resonate faintly, producing electromagnetic pulses every 8 hours. The lab fell silent. The pulse matched the rotation period of 3I Atlas. Coincidence, perhaps, or imitation. But it was enough to unnerve even the most rational minds. Data was shared across networks under encryption. No one wanted to claim discovery, but no one could ignore the result. If the alloy's properties could be replicated, it meant that 3I Atlas's mystery was not supernatural, merely ahead of us. And yet, the deeper the experiments went, the more unsettling the implications became. The resonance persisted even after the magnetic field was turned off. The material had learned the oscillation. Days later, it still emitted faint signals like an echo refusing to fade. The press was never informed. The public saw only the headlines about nickel anomalies and spectral analysis, unaware that in the basements of the world's most advanced laboratories, humanity had begun to play with the echoes of an interstellar logic. By mid-November, the research fractured into two camps. The first insisted that the alloy's behavior was natural, the result of a stable quantum phase transition. The second whispered of self-organization, of systems that evolved toward order not by design, but by the hidden mathematics of the cosmos. Dr. Baranov published a controversial paper titled Entropy Loops and the Spontaneous Memory of Matter. In it, he suggested that matter, given enough time, develops structures that preserve information about their energetic past, that even atoms possess a faint capacity for remembering patterns. To him, 3I Atlas was not a machine, but a fossil, a preserved state of order so perfect that it simulated intention. Others disagreed. If the universe could create materials that behave like devices, what difference remained between artifact and nature? Where did intelligence begin? In neurons or in structure? The debate rippled quietly through academia. Behind every equation lurked a deeper unease. Maybe consciousness was not unique to biology. Maybe the architecture of order itself, crystalline, metallic, quantum, was another form of awareness, one that had no need for life to express it. Outside the laboratory walls, the world carried on. But for those who handled the alloy samples, something subtle began to change. Late at night, in the hum of cryogenic chambers, they could almost feel the rhythm, the same pulse that once echoed from the comet across the void. It was steady, patient, eternal. One night in Zurich, the resonance monitor flashed unexpectedly. The pulse had shifted just slightly, a new harmonic emerging, as if the material were adapting. When the scientists reviewed the logs, the anomaly was gone, its trace erased in noise. But the instruments had recorded a single clear oscillation unlike anything before, one beat that did not belong. It might have been an error, or it might have been the alloy's final whisper, a reminder that the line between replication and reanimation is perilously thin. By winter's end, the teams paused their work. The data was archived under neutral language labeled phase stability under non-equilibrium conditions. the story would never reach headlines. The world would never know that humanity had, briefly built in miniature, the echo of something from beyond its sky. But those who were there remembered. They remembered the moment when their instruments sang, faintly, rhythmically, impossibly, as if a voice had crossed the gulf between stars and chosen to speak through metal. They remembered the sound of the impossible becoming real. And as they powered down their machines, a thought lingered in every mind. Perhaps the universe does not hide its secrets from us. Perhaps it simply waits, patiently, until we build the tools to hear them again. By December 2025, the object that once shimmered across the telescopes of Earth had vanished from human sight. The Atlas was gone, a metallic ghost dissolving into interstellar dark. Yet even as its physical presence faded, its riddle only deepened. The data that had been gathered over those frantic months refused to behave. Every model, every simulation, every reconstruction failed to capture the precision of what had been observed. Its light curves, its nickel emissions, its periodic pulses, all aligned with eerie regularity, as though every layer of the object had been tuned to a single principle: coherence. In scientific databases, the term 3I Atlas anomaly became a placeholder for ignorance, a polite way of saying we don't know. And so the focus shifted from observation to interpretation. What was it that humanity had truly witnessed? It began with the radio archives. The Deep Space Network, Meerkat, and FAST telescopes each held months of raw telemetry, data too vast to parse in real time. Now reprocessed through AI-enhanced filters, the signals revealed faint substructures hidden within the noise. What once appeared as uniform pulses now showed microscopic fluctuations like modulation within modulation. Each burst carried internal echoes, recursive harmonics, self-similar and fractal in form. The discovery sent a tremor through the International Research Consortium. Could this be mere thermal resonance? A coincidence of rotation and material stress, possibly. But the repeating harmonics hinted at something organized, a hierarchy of frequencies nested within one another, scaling perfectly with rotation period and distance from the sun. Patterns like this do not emerge from chaos. They emerge from law or intent. In Tokyo, a mathematician named Kiyoshi Endo began analyzing the intervals between harmonics, searching for order. When he plotted the data, a strange geometry unfolded. The ratios between pulses matched a sequence known from harmonic crystallography, a pattern seen in the spacing of atomic lattices. The object's radio emissions, in effect, mirrored the structure of its metal. Atlas was not only reflecting light, it was echoing its own architecture through electromagnetic song. No one called it communication, not yet. But in private correspondence, some scientists whispered the unthinkable, that perhaps information could be encoded not in language, but in physics itself. A message not from intelligence, but of intelligence, the universe expressing cognition through structure. The idea was seductive, almost mystical. And yet as weeks passed, further analysis lent it a strange plausibility. When researchers overlaid the harmonics onto nickel's natural resonance frequencies, the alignment was near perfect. It was as if the metal itself had been tuned to amplify its atomic voice, a bell designed by nature, or by something that understood nature intimately. Meanwhile, radar data from Goldstone underwent a fresh review. In the original models, the comet's shape had been uncertain, blurred by noise. Now, using refined algorithms, scientists reconstructed a faint 3D profile. What emerged was unlike any known comet or asteroid. It was not spherical nor irregular. It showed long, planar faces, broad surfaces meeting at shallow angles, giving the silhouette of a faceted object. Nature could carve symmetry. But this symmetry was purposeful. Across institutions, skepticism gave way to fascination. Astronomers compared the shape to interstellar mineral crystals, vast metallic lattices grown by the slow freeze of plasma clouds. Material scientists countered that such geometries on that scale required guidance. The debate split into factions, the naturalists versus the intentionalists. The naturalists argued for physics, for a cosmic origin of precision. Perhaps Atlas had formed in the wake of a neutron star's magnetic storms, where atomic alignment occurs spontaneously under conditions unknown to our solar system. Under such pressures, alloys could crystallize into symmetry indistinguishable from design. The intentionalists proposed another vision, that somewhere, far away, intelligent hands and/or intelligent laws had once forged these alloys deliberately, perhaps not for travel, perhaps not for life, but as remnants of technology so old its creators had turned to dust, while their work continued to drift among the stars. Neither side could prove the other wrong. At ESA headquarters in Paris, a psychologist invited to the working group made an observation that stilled the room. Perhaps, she said, the conflict is not about evidence but about comfort. The idea that matter itself can organize into meaning without a mind behind it frightens us more than the idea of aliens ever could. The silence that followed felt heavier than data. Meanwhile, the signals from Atlas, now impossibly faint, still reached Earth. Every week, the Deep Space Network caught a final flicker, a pulse almost indistinguishable from background static. And yet, when filtered through narrowband analysis, its rhythm persisted. Even in retreat, the visitor continued to hum, like a star long dead still casting echoes through space. In a quiet office in Zurich, Ilya Baranov, the physicist whose lab had once recreated the nickel resonance, began to map the fading pulses across time. What he found chilled him. As the object moved farther away, its period lengthened not linearly but logarithmically, matching a decay curve seen in systems that adapt. The pulse was not fading uniformly. It was responding to distance. Was it feedback? Or something deeper? He sent his findings to colleagues in Pasadena and Tokyo. The response was cautious. The math was sound, but the implication too bold. If the pulse adjusted with distance, then Atlas was aware. Not in consciousness, perhaps, but in state. It was reacting to its environment, maintaining coherence until the universe itself finally silenced it. The news never reached the public. The data was filed quietly under thermal evolution, explained away as nonlinear cooling. Yet the truth, or at least the mystery, lingered in those who had seen it. By late December, an unofficial consensus had emerged among the researchers who had devoted their lives to the study. 3I Atlas was not a probe, nor a ship, nor an accident. It was something rarer, a structure that behaved as though it remembered the process of its own creation, a body that carried within it the song of the star that forged it. And so, in academic journals and whispered conferences, a new term entered the scientific vocabulary: self-echoing matter. It described any structure whose physical properties preserved and repeated the energy signatures of its formation. Atlas was the first and only known example, but its existence forced an impossible question. If one such body could exist, How many others drift through the galaxy, humming the memory of their birth? Humanity might never know. But the implications stretched beyond science. For in that single metallic traveler, the cosmos had revealed a subtle truth, that not all intelligence must think, and not all messages must be written. Some are built into being itself. In the end, as 3I Atlas faded beyond the reach of every telescope, its echo remained, not in data, but in minds. A reminder that the universe does not need witnesses to express wonder. It only needs motion, order, and the patience of eternity. And somewhere far from the sun's warmth, the nickel heart of 3I Atlas still turned in silence, not dying, not decaying, just remembering. By early 2026, the scientists who had spent months chasing the metallic ghost of 3I Atlas found themselves facing a philosophical divide. The object had left their telescope's range, but its data refused to leave their thoughts. Each fragment of evidence, the nickel emissions, the rhythmic pulses, the thermal equilibrium, could be explained only by invoking extremes of temperature, of magnetism, of cosmic violence. The question was simple but devastatingly deep. Could nature itself produce an object so disciplined it resembled art? Those unwilling to invoke alien hands turned toward the universe's most ferocious factories, the hypernovae and neutron starbursts that scatter heavy elements like divine sparks across the galaxy. In these crucibles, matter is stripped of order, fused, crushed, and then expelled at relativistic speeds. A single event can outshine an entire galaxy, its light carrying the spectral signature of elements newly born. It is here, the naturalists argued, that something like 3I Atlas might have originated. A fragment from the heart of catastrophe. Nickel, especially nickel 56, is abundant in such environments. When the core of a massive star collapses, iron and nickel nuclei form in rapid succession. Some of this material becomes radioactive, its decay illuminating the supernova's afterglow. But in rare cases, the explosion doesn't disperse the material evenly. Instead, pockets of molten metal can cool mid-flight, hardening into crystalline alloys under pressures no laboratory can reproduce. Imagine a droplet of molten metal solidifying as it races through a storm of radiation, its atoms freezing into geometric harmony, while magnetic fields millions of times stronger than any on Earth twist its structure into order. Such an object could, in theory, become what Atlas appeared to be, a stable metallic crystal, born not by intelligence but by the physics of chaos. At CERN and Riken, simulations of these cosmic forges began in earnest. Researchers recreated the thermodynamic pathways of nickel formation inside exploding stars. The models showed that under specific conditions, where a supernova's magnetic field aligns with its rotation, metal can cool into long planar sheets, layered like microscopic armor. Such structures could, in principle, reflect light in periodic patterns and even sustain residual electromagnetic oscillations. It was a breakthrough of sorts, a bridge between mystery and possibility. But it came at a cost. If 3I Atlas was natural, then nature itself was far stranger than humanity had imagined. In a paper circulated quietly among research circles, Dr. Kiyoshi Endo wrote, "The line between cosmic physics and architecture may be an illusion. The universe, in moments of sufficient violence, builds with the precision of intention. This notion, that nature could sculpt order so perfect it mimics design, reshaped the debate entirely. Perhaps intelligence was not a prerequisite for complexity. Perhaps the cosmos, given enough energy and time, self-organized into patterns indistinguishable from purpose. The evidence deepened when new simulations from NASA's Goddard Space Flight Center suggested another possibility: that Atlas might have formed not from one event, but from a chain of stellar cataclysms. A piece of metal born in one supernova could have been captured by another forming system, reprocessed by heat and expelled again, a nomadic atom, reforged across eons. Each passage would align its atomic structure further, tuning it like an instrument struck repeatedly by the same cosmic hand. Such an origin, though purely natural, bordered on mythic. It made Atlas not just a traveler between stars, but a relic of multiple universes of fire, a survivor of destruction turned into stability. Even so, questions persisted. The stability of its nickel glow, its balanced rotation, and the apparent memory of its structure all stretched these models to their limit. Theories grew wilder. Some invoked magnetar crusts, the dense metallic skins of neutron stars where atoms are pressed so tightly they begin to behave collectively, forming a single quantum. The question had been whispered for months, then avoided for fear of ridicule. But by the dawn of 2026, it was no longer taboo. The symmetry, the signals, the metallic coherence, they were not the fingerprints of chaos. They looked increasingly like intention. A new word began appearing in the research logs, cautiously typed in lowercase letters: artifact. It did not mean alien spacecraft, not yet. It meant something that existed for a reason, something built, not accidentally assembled by the indifferent machinery of physics. And so began the most controversial phase of the 3I Atlas investigation: the search for signs of intelligence. The idea of technological relics in space was not new. Theoretical physicist Ronald Bracewell had proposed as early as 1960 that advanced civilizations might scatter autonomous probes, messengers, throughout the galaxy, designed to drift silently until they encountered a civilization capable of noticing them. Decades later, the notion evolved into the concept of von Neumann's self-replicators, machines that build more of themselves, colonizing the stars not with biology, but with metal. For most of scientific history, such ideas had remained confined to the peripheries of thought, fascinating, poetic, and unprovable, until now. When the data from 3I Atlas was re-examined through this speculative lens, old anomalies began to take on unsettling coherence. The structured radio pulses, once dismissed as thermal resonance, could, in principle, be a form of passive information encoding. The object's geometric facets might not be natural planes, but the eroded remnants of engineered surfaces. Its stable rotation and constant thermal equilibrium, once scientific curiosities, could just as easily serve as mechanisms for regulation, efficiency, and endurance. If so, 3I Atlas was not a wanderer. It was a survivor. The intentionalist camp gathered momentum. Avi Loeb, already known for his insistence that Oumuamua could have been a fragment of alien technology, revisited his earlier arguments in the context of Atlas. His papers, though still controversial, resonated in a way they hadn't before. The data fit too well. What if, Loeb posited, these interstellar objects were not coincidences but signs, fragments of cosmic industry, or artifacts abandoned by civilizations so ancient their creators were now only myths written in dust? The idea divided science. To some, this was a dangerous regression into mythology. a surrender of skepticism. To others it was simply curiosity, sharpened by evidence. After all, the universe was old beyond comprehension, and human civilization was barely a spark in the dark. If intelligent life had risen elsewhere, long before Earth cooled, its remains could already be drifting between stars, broken, silent, waiting to be noticed. At NASA's Jet Propulsion Laboratory, a small interdisciplinary group began studying the possibility under the code name Project Echo. Its aim was not to prove intelligence, but to test whether the data from Atlas could be explained through engineering logic, rather than natural formation. They began by mapping the object's reflectivity against its rotation. The pattern was startling. 4 primary peaks evenly spaced with harmonics at intervals consistent with structural segmentation. The simplest model and a rough sphere could not reproduce the data, but a faceted object with uniform planar sections did. It was as if Atlas had once been composed of panels, not smooth now, but long eroded, edges softened by eons of radiation. The next revelation came from energy balance calculations. The object absorbed sunlight inefficiently, less than half the expected albedo of nickel-rich alloys. Yet its thermal emission remained steady. It was as though the surface had been designed to reflect excess heat. On Earth, spacecraft use similar principles to regulate temperature in space. Bright coatings, reflective panels, radiative symmetry. The resemblance was uncanny. Still, science demanded humility. For every engineered analogy, there existed a possible natural twin. Supernova ejecta could yield planar crystal growth. Thermal equilibrium could arise from internal composition. Yet as the patterns compounded, the burden of coincidence grew heavier. By February, the term technosignature re-emerged. Not in press releases, but in internal memos. It referred not to radio signals or artificial lights, but to any physical trace of technology measurable by natural science. For decades, SETI had listened for messages. Now perhaps the universe had sent one in silence. At the SETI Institute, an aging researcher named Marta Ruiz revisited the earliest data. She noticed something others had overlooked. A faint phase shift in the object's rotational rhythm, occurring once every 9 cycles. The pulse dimmed slightly, then returned, a heartbeat with an occasional stutter. On a hunch, she plotted the intervals as binary, bright as 1, dim as 0. The pattern repeated, 1000, 1001. Her colleagues laughed. A statistical coincidence, a thermal artifact, but she couldn't shake the feeling that something, or someone, had wanted to be found. When the story leaked online, it ignited a storm. Headlines screamed, "Alien code hidden in interstellar object." Conspiracy channels proclaimed contact. Governments issued denials. The scientific community recoiled from the chaos. Ruiz, under pressure, withdrew her analysis. But the damage was done. Public imagination had fused with cosmic wonder, and yet beneath the hysteria, the professionals continued to study quietly. ESA's data group confirmed the periodic dimming, but attributed it to tumbling geometry, not intelligence. NASA's advisory board issued another statement. There is, at present, no evidence of artificial origin. But in the corridors of private conversation, disbelief had softened. No evidence no longer meant no possibility. One evening during a private symposium in Chile, Dr. Nadia Rains, who had once recreated the alloy in the lab, spoke words that silenced the room. "If it is artificial," she said, "then it's not from a civilization like ours. It's older than civilization itself. Whatever made it no longer exists, but the laws it understood still do. That idea lingered, hauntingly beautiful. Intelligence not as a species, but as a phase of matter. A kind of thinking metal forged by physics itself. Consciousness distilled into structure. Perhaps the object was never meant to send a message. Perhaps it was the message. A fragment of an older universe that once knew how to encode knowledge into alloy, and sent it drifting through space as memory. As the debate raged, 3I Atlas continued its slow retreat into the void. The last detectable pulse, faint, fractured, and nearly indistinguishable from background noise, arrived at the Deep Space Network in late February. Then silence. Still, for those who had stared into its spectrum, the silence did not feel empty. It felt deliberate. It was as though something had finished saying what it needed to say. The event fractured astronomy, philosophy, and theology alike. For millennia, humanity had searched for voices among the stars, expecting language, pattern, or reply. But what if the universe spoke in form instead of words, and in the curve of orbit, the hum of metal, the geometry of endurance? Perhaps intelligence was not extinguished. Perhaps it had evolved beyond communication, choosing instead to leave behind objects that explain themselves through their very being. And so, the question of 3I Atlas ceased to be scientific alone. It became existential. If intelligence can outlive biology, if purpose can be embedded in matter, then consciousness itself is not limited to minds. It is written into the universe's fabric. Every star, every planet, every atom may be, in its own way, a fleeting experiment in awareness. When the final report was published, its conclusion was characteristically modest. The properties of 3I Atlas remain consistent with both extreme natural processes and speculative artificial hypotheses. Further data is required, but in the margins of one scientist's notebook found years later was scrawled a line no journal would have printed. Maybe the universe doesn't build machines to explore itself. Maybe it builds us. By mid-2026, the mystery of 3I Atlas had become something more than a scientific debate. It had become a philosophical fracture line, running straight through the heart of astrophysics. The object had long since vanished into the black. Yet on every continent, laboratories still chased its ghost. The chemical ratios, the spectral lines, the inexplicable endurance of its metallic heart. And everywhere the same paradox persisted, the alloy that should not exist. Nickel and iron are among the most ordinary metals in the universe, forged in the hearts of dying stars and scattered across the Milky Way like cosmic dust. But in 3I Atlas they had arranged themselves into something extraordinary, a lattice that behaved as if guided, a structure that refused to obey the randomness of its birth. Months of experiments yielded a single, unsettling truth. The alloy was too perfect. Under electron microscopy, samples of replicated Atlas composition, forged under ultra-high magnetic fields and rapid cooling, revealed minute alignment patterns, microscopic domains that echoed across scales. In typical meteorites, metallic grains twist and fracture. Entropy carves them into beautiful disorder. But in these tests and in the data retrieved from Atlas, the arrangement was nearly crystalline. Long, continuous pathways of alignment. As if every atom knew precisely where to stand. Such structure should be unstable. It should relax, bend, collapse into randomness. And yet, both in simulation and in the cosmos, it endured. Physicists called it the metallurgical paradox. the coexistence of absolute order and absolute survival. Dr. Raines, whose experiments had once reproduced the object's faint resonance, compared the phenomenon to a frozen wave. Energy suspended, never dissipating. "It's like a standing note in matter," she said. "A vibration that decided to stay." Others approached from theory. In Cambridge, a materials physicist named Elon Crow proposed that the alloy existed in a metastable quantum phase, a condition that defies conventional temperature boundaries. In such a phase, electrons could form standing patterns that reinforce one another, maintaining coherence like ripples locked in a circle. It would mean the metal itself was not passive but dynamic, a system perpetually reorganizing to preserve its equilibrium. The math worked. The chemistry didn't. For the alloy to exist in that state, it would need energy. Not much, but constant. Somewhere, somehow, 3I Atlas must have been feeding itself. This realization gave birth to one of the strangest ideas in modern astrophysics, that perhaps 3I Atlas was thermodynamically active. Not alive, not thinking, but behaving as though it refused to surrender energy. A self-balancing relic, powered not by reaction but by memory. A handful of theoreticians began whispering a phrase that made others uncomfortable: energetic recursion. They suggested that the alloy might be recycling the same quantum energy internally, like a closed loop. The object could travel for millennia without changing temperature or structure because it was not decaying at all. It was remembering its initial state, constantly reasserting it against entropy. When the hypothesis reached the press, it was twisted beyond recognition. Alien metal that heals itself. But behind the sensationalism lay a haunting truth. In a universe ruled by decay, here was a fragment that refused to die. Meanwhile, computer models grew more precise. By feeding all known data, thermal, spectral, and radio, into a high-resolution simulation, researchers at the Los Alamos laboratory reconstructed a digital version of 3I Atlas's surface. What emerged was breathtaking, a geometry not chaotic but layered, rippling with symmetry at every scale. Some saw the structure of fractal crystal growth. Others saw the unmistakable logic of design, and the deeper the model went, the more profound the symmetry became. Each layer reflected the ratios of the one above it, like music transposed into matter. Scientists began to wonder whether they were looking at the first example of hierarchical metallurgy, a structure built from recursive alignment, repeating itself from atomic scale to macro form. If so, it would mark a new state of matter entirely. Not solid, liquid, or gas, but architectural. A few dared to speculate aloud, perhaps the universe, through sheer accident, had stumbled upon a configuration of atoms so precise that it functioned like an algorithm, matter that computes its own persistence. This idea, matter as memory, memory as persistence, brought back an older theory, one buried in the footnotes of quantum physics, the notion that information is not destroyed in the universe, only rearranged. If 3I Atlas had encoded its formation within its metallic lattice, it might literally contain its own history, written in structure rather than words. In a poetic sense, the object might not only remember, it might replay itself. But the paradox was not purely academic. The lab in Zurich, Baronoff's lab, began observing phenomena that verged on the eerie. The synthetic alloy sample, locked in cryogenic containment, displayed a faint, periodic temperature fluctuation every 8 hours. precisely matching the rotation cycle of 3I Atlas when it was near the Sun. No external energy was applied. No explanation fit. Engineers replaced the sensors, recalibrated the chamber, even moved the experiment to a different facility. The pattern persisted. It was as though the sample had synchronized with its cosmic origin, resonating across light years, replaying the same rhythm that had once echoed through the void. Some dismissed it as coincidence, others as experimental noise. But those who had seen the original pulse in the Atlas data, that steady hum of metal in motion, recognized it instantly. The rhythm was not coincidence. It was memory. For a time, the phenomenon became an obsession. Researchers measured every shift, every oscillation, hunting for meaning. Some thought it a message, others merely the echo of material physics. In the end, the data provided no words, only recurrence. The alloy, like its parent, seemed content to be. By summer, the Zurich sample was sealed away, labeled as unstable due to unexplained energy fluctuations. Yet as the lights dimmed and the equipment powered down, a single thought haunted those who had worked on it. If this was what 1 gram of replicated Atlas material could do, what might an entire celestial body be capable of? Perhaps 3I Atlas was not built to communicate. Perhaps it was built to endure. And endurance in its purest form is a kind of intelligence. That was the heart of the metallurgical paradox, the line between natural perfection and intentional survival. Was 3I Atlas a geological miracle, a relic of forces too vast to imagine? Or was it evidence that intelligence can exist without thought, awareness without will? The final report on the alloy closed with words rarely found in scientific literature. At this point, we cannot determine whether the observed coherence is the result of design, emergence, or an unknown category of physics. In the object, these distinctions appear meaningless. In that single sentence, the boundary between science and philosophy dissolved. Because if matter can preserve its own pattern, if it can defy decay not through magic, but through structure, then perhaps the very essence of intelligence is written not in neurons, but in persistence. And somewhere beyond the reach of light, a fragment of nickel and iron continued its silent computation, drifting through eternity, a thought that never stopped thinking itself. By the spring of 2027, the mystery of 3I Atlas had evolved beyond astronomy. It had become a quiet global collaboration, a tapestry of instruments and minds stretched between worlds. The object was long gone, its trajectory charted into infinity. But its echo lingered, not only in data, but in the machines that had dared to look at it. The instruments that first glimpsed its metallic light were now themselves part of its story. The story of how humanity saw something it could barely comprehend. It began, as most modern revelations do, with mirrors and silence. The James Webb Space Telescope, stationed 1 million miles from Earth, had been among the first to capture Atlas's spectral truth. When its golden panels unfolded in 2022, it had been built to search for the first galaxies, not for interstellar artifacts. Yet in July 2025, JWST's mid-infrared detectors recorded an object that glowed faintly even in darkness, as though defying the cold of the void. The readings were too coherent, too even for dust or ice. It was the telescope's operators who first described it, quietly, in logs not meant for publication, as a machine made of temperature. Months later, the Atacama Large Millimeter Array, ALMA, joined the watch. High in the Chilean desert, where the thin air lets cosmic whispers through. The array dissected the object's electromagnetic voice. Its signals danced between noise and intention, narrow band bursts rhythmic regular. Engineers had designed ALMA to listen to molecules, the birth cries of stars. Yet as 3i Atlas passed within range, it became something else entirely, a stethoscope pressed against the pulse of an alien alloy. The Hubble Space Telescope, older but persistent, contributed its vision in visible light. It saw not wonder but simplicity, a gleaming point with no tail, no chaos. The orbit confirmed hyperbolic motion, escape velocity beyond our sun's reach. To Hubble's cameras it was just another light, and yet, its steadiness betrayed its uniqueness. And far below on Earth, the Gemini Observatory, Vera C. Rubin Observatory, and FAST, China's giant radio ear, formed the terrestrial trinity of observation. Together they synchronized humanity's perception into something almost divine, a network of eyes and ears spread across continents, all fixed on a single, indifferent traveler. Each instrument recorded a fragment of truth, frequency, reflection, temperature, composition, but none alone could explain it. Only when their data overlapped did the shape of the impossible emerge. The most astonishing finding came not from the telescopes, but from an intersection of their measurements. When JWST's infrared curve was overlaid with ALMA's radio data, the frequencies aligned in perfect harmonic ratios. The same pattern, the same mathematical order appeared both in light and in radio. It was as if the object emitted a symphony across the spectrum, each wavelength a note in a cosmic chord. For the scientists who saw it, the discovery felt almost spiritual. Nature could be chaotic, even elegant, but harmony across spectra? That was design, whether by mind or by law. ESA's analysts called it multimodal coherence. NASA's physicists used a different term, structural resonance. But one researcher, a linguist working with the SETI Institute, called it something else, syntax. To her, the patterns looked like grammar. Not language as humans know it, but structural consistency. An order that persisted across media. In essence, the alloy spoke the same way in light as it did in sound. Her paper was dismissed as poetic, unscientific. But her observation remained. Atlas was coherent. And coherence is not the universe's default state. Meanwhile, the Comet Interceptor mission, originally scheduled for 2029, was quietly redesigned, its new objective to prepare for the next one. The next 3i should another interstellar visitor arrive. Engineers worked obsessively to equip it with automated intercept trajectories, ready to launch at a moment's notice. They called it Project Horizon. Its stated goal was to study an interstellar body in real time. Its unstated dream was to touch one, to feel the metal that once sang across the sky. In Geneva, the CERN Material Science Division partnered with ESA to build miniature analogs of the Atlas alloy, using ultra-high vacuum deposition techniques. The devices were small, each thinner than a human hair, yet their purpose was monumental: to test whether the spectral properties of the interstellar object could be mimicked in controlled conditions. What they found startled everyone. When exposed to alternating electromagnetic fields, the synthetic nickel-iron lattice began to resonate at frequencies identical to those observed by ALMA 2 years earlier. The alignment was exact, down to the 10th decimal place. It was as if the universe had already designed the blueprint, and all humanity had done was trace it. For the first time in history, a phenomenon once seen through telescopes had been coaxed to whisper again in a lab. The hum was faint, measurable only through atomic sensors, but it was unmistakable. In that moment, the boundary between observation and creation blurred. Humanity was no longer just a witness. It was a participant. The excitement was tempered by caution. These instruments, JWST, ALMA, Hubble, FAST, had not merely detected something extraordinary. They had changed it by looking. Every measurement, every photon caught had rewritten part of the mystery. The object's very identity now existed as an intersection of human perception and cosmic indifference. And so, scientists began to ask the forbidden question: did we record 3I Atlas or did we alter it? Quantum theory had long taught that observation changes the observed. Could the coherence of Atlas, its rhythm, its harmony, have been amplified by our active attention? Could the object, inert and distant, have responded to the gaze of instruments that share its elemental kinship? For every mirror, every detector, every polished lens, all are made of atoms born in the same stellar furnaces. Perhaps one theorist suggested the object wasn't simply seen, it was recognized. By now, the study of 3I Atlas had grown to involve over 400 institutions, 12 space agencies, and thousands of researchers. But beyond the data, a quiet transformation was taking place. Not in the stars, but in humanity's perception of itself. The instruments had revealed more than metal. They had shown a mirror. In the spectral glow of an object that refused to decay, humankind glimpsed its own hunger, the desire to persist, to be remembered, to turn observation into creation. Every instrument pointed skyward was also a reflection of that same drive. The telescopes were not just eyes, they were declarations. We are listening, and what they heard. The steady hum of coherence, the whisper of order in the dark, and was perhaps the faintest confirmation that the universe had been listening, too. In the final months of the study, JWST's last observation window closed. Its final image of 3I Atlas showed nothing but background radiation, no light, no trace. But when the data was filtered through deep spectral analysis, a faint harmonic spike remained, and too small to classify, too elegant to ignore. It was the same frequency that ALMA had recorded a year earlier. The hum persisted. Somewhere, beyond every lens and mirror humanity had ever built, 3I Atlas still existed, unseen, untouchable but not silent. Its resonance now lived inside the instruments that had tried to understand it. Their data, their circuits, their software, all vibrating with the same invisible frequency. The alloy's song had crossed from the cosmos into code, and though the telescopes turned away, their legacy remained, a planet filled with machines humming faintly to themselves, replaying the rhythm of an interstellar visitor, as if the universe had taught them a tune they could never forget. By 2028, the name 3I Atlas had become both a triumph and a wound in the scientific record. A moment of seeing that expanded human vision, yet exposed the boundary where sight ends and meaning dissolves. No one had glimpsed the object in over 2 years. Its light had faded beyond detection. Its hum no longer reached even the most sensitive arrays. The universe had swallowed it again. What remained were numbers, spectral graphs, frequency charts, lattice simulations, and the silence that followed. At first, researchers refused to let it go. Every new telescope calibration, every fresh burst of data from deep space was checked for echoes of the vanished signal. But 3i Atlas was gone. In its absence, something more difficult to study had taken its place: doubt. For centuries, science had thrived on certainty, on the conviction that given enough time, enough instruments, and enough intellect, the universe would yield its secrets. 3i Atlas had shattered that illusion. It was not that the data were missing. It was that the data defied completion. Every attempt to explain it led to contradictions. If it was natural, it behaved too precisely. If artificial, it was too ancient, too indifferent. The object refused to sit on either side of the line that divides creation from emergence, mind from matter. It was the perfect anomaly, one that proved not ignorance but humility. In the halls of academia, the tone changed. The scientific papers that once spoke with authority now trembled with uncertainty. Words like likely, possible, and consistent with became lifelines in an ocean of unknowns. The great journals filled with cautious language, elegant footnotes acknowledging the unbearable truth that there are limits to knowing. A young cosmologist in Kyoto summarized it best. 3i Atlas, she wrote, is a reminder that understanding is not the end of mystery but its beginning. The debates that had once divided the field began to blur. The naturalists and intentionalists, once enemies, found themselves quietly united in awe. Whether by physics or purpose, the object had achieved something neither side could replicate: coherence beyond chaos, meaning beyond context. It had outlasted explanation. At conferences, speakers began invoking older metaphors: the shipwreck in the dark, the fossil of time, the mirror of intelligence. Philosophers joined the conversation, arguing that perhaps 3i Atlas was not meant to be understood at all. Perhaps its purpose, if it had one, was to restore mystery to a species that had started to mistake knowledge for wisdom. Even Einstein's old warning found new life. The most beautiful thing we can experience is the mysterious. He had written those words long before humanity built telescopes that could peer into creation itself, but their resonance had never felt sharper. For the engineers and physicists who had dedicated years to decoding the object, acceptance did not come easily. They were trained to chase answers, not reverence. Yet as the months stretched into years, the silence from the stars became its own kind of message. Not absence, but completion. A cosmic full stop. The more they reflected, the clearer it became. 3i Atlas had changed science not by what it revealed, but by what it withheld. It had reminded the world that truth is not a destination but a landscape, one where certainty and mystery coexist, layered like the very metals that compose the traveler itself. At the Los Alamos laboratory, where a digital model of the object still ran on a closed server, researchers noticed something strange. Each time the simulation looped, reconstructing the temperature curve, the magnetic field, the radio pulse, it diverged slightly, as though the algorithm could never perfectly recapture the original pattern. Over thousands of iterations, the object's digital twin began to evolve. The alloy's simulated lattice shifted subtly, developing new symmetries that were not in the original data. Some dismissed it as a computational artifact, a rounding error. Others were not so sure. Perhaps, one theorist mused, this is what understanding really is: a conversation that changes both sides. As 3i Atlas faded from the data streams, its essence seeped into other fields. Biologists began citing its self-organizing behavior as a model for protein folding. Philosophers used it to illustrate the paradox of perception. Even artists borrowed its imagery: the eternal traveler, the humming metal, the unknown intelligence. It became a myth of modernity, the day the universe gave us a question we could not answer. And yet it was not despair that followed. It was reverence. Because within that unsolved question lay something profoundly human. The ability to stand before the infinite and still reach outward, knowing the answer may never come. In Geneva, at the headquarters of the European Space Agency, a plaque was quietly mounted in the central atrium. It bore no image, no dates, no technical details. Only a simple inscription, Atlas, discovered July 1, 2025, lost. December 2025, still speaking. Below it, engraved in smaller letters, were words that would come to define a generation of scientists. We looked, and were changed. In the years that followed, new interstellar candidates were detected, faint, unremarkable, fleeting. None displayed the same brilliance, the same spectral strangeness. Atlas remained alone, a singular note in a song too vast to comprehend. But in every observatory, every classroom, and every quiet mind still haunted by its light, the lesson endured. There is no final answer in a living universe. Every revelation carries its own unknowing. Every discovery another layer of wonder, and so, the mystery of 3I Atlas became a new kind of knowledge, one written not in certainty, but in surrender. Humanity, for all its instruments and algorithms, had once again met the edge of comprehension, and though it could not cross it, it could finally see that the edge was not a wall, it was a horizon, a place not to end the journey but to begin it anew. Years had passed since the last pulse of 3I Atlas faded into cosmic silence, and yet its influence deepened rather than dimmed. The object itself was gone, traveling an infinite road between the stars, but the idea of it had become immortal, a resonance that lived not in data, but in human thought. It began quietly. Graduate students wrote theses on coherence anomalies. Philosophers convened conferences on emergent intelligence. Artists painted the unseen hum of the cosmos in shades of nickel blue and iron gray. Musicians composed pieces based on its harmonic ratios, transforming the cold mathematics of its spectrum into the language of grief and beauty. For centuries, science had given humanity knowledge. But 3I Atlas had given it meaning, a reminder that mystery itself is sacred. The world's observatories, once frantic with measurement, learned to listen differently. The Very Large Telescope in Chile began a long-term project cataloging faint metallic comets, searching for spectral cousins of Atlas. None matched. Each one, natural, disordered, silent, only deepened the original miracle. The James Webb Space Telescope, its mirrors now faintly dulled by cosmic dust, turned its gaze toward more distant galaxies. Yet its operators sometimes joked in hushed tones that every dataset seemed to carry a trace of Atlas, a faint harmonic bump near 10 microns, subtle, ghost-like. No one could tell if it was a software artifact or a cosmic fingerprint, but no one wanted to erase it. The hum had become part of the universe's story, and perhaps part of ours. In classrooms and documentaries, Atlas became a symbol of intellectual humility, proof that discovery need not end in understanding to matter. Its story was told beside those of Oumuamua and Borisov, yet it stood apart. The others were visitors. Atlas was a question. At the Zurich Institute for Quantum Materials, the sealed alloy sample, the one that had once pulsed faintly in rhythm with the interstellar object, remained stored in a cryogenic vault. Officially, it was inert. Unofficially, technicians claimed otherwise. They said that on certain nights when the lab was empty and the room lights dimmed, the containment sensors registered a pulse, a micro-oscillation too regular to be random. It came every 8 hours, then faded, leaving no trace. When asked, the director would only smile and say, "Instruments remember too." Outside the walls of science, the story had become myth. Poets wrote of a traveler made of light and will. Filmmakers imagined civilizations that encoded their consciousness into metals to survive the death of stars. Theologians debated whether 3 Atlas was a sign, not of God, but of creation's continuity, the divine written not in scripture but in chemistry. For others, it became something simpler: hope. If the universe could craft such perfection without intention, then perhaps beauty required no author. Perhaps existence itself was art, the slow, patient sculpting of order from chaos, until even metal began to remember its origin. But among scientists, a subtler realization grew. Atlas had forced them to see that intelligence, as they understood it, was not unique to the biological. Intelligence was structure, persistence, the ability to organize against entropy. And by that definition, the universe itself was intelligent. Every atom that found stability, every star that balanced fusion and gravity, every galaxy that spun for eons in fragile equilibrium, all were acts of self-organization, the physics of endurance that mirrored thought. Atlas had not spoken, and yet it had communicated the oldest truth, that existence itself strives to continue. In 2028, the International Astronomical Union renamed the catalog of interstellar bodies. The I no longer stood merely for interstellar. It stood for interlocutor. A silent nod to the idea that these visitors were not just travelers, but participants, cosmic interlocutors in the grand dialogue between matter and mind. That same year, a new generation of instruments began construction. The resonance array, a network of synchronized detectors stretching across the globe, designed not to search for light but for rhythm. Its purpose was radical: to listen for coherence, not noise, to find the harmonies that hint at order born without guidance. Some called it humanity's first attempt to converse with the physics of intelligence itself. When it went live, the first recordings revealed nothing unusual, only the familiar hiss of cosmic background radiation, the gentle roar of galaxies. But deep within that roar, in one narrow frequency band, a faint oscillation appeared. Regular, steady, elegant. At first, no one believed it. It could not be 3I Atlas. The object was gone, its trajectory tens of billions of kilometers beyond reach. Yet the signature was identical. The scientists checked every system. They recalibrated, rebuilt, reanalyzed. The signal remained. It was faint, weaker than static, but mathematically precise. A harmonic whisper threading through the noise of the cosmos. When the analysis was complete, the result was both thrilling and humbling. The signal was not coming from a single point, but from everywhere. Every direction. It was as though the hum of 3I Atlas had never ended. It had simply blended into the background of reality itself. The faintest rhythm in the structure of existence. No one could explain it. Some said it was coincidence. Others said it was confirmation. Proof that coherence was not anomaly but inheritance. That the entire cosmos carried within it the same vibration, the same will to endure, the same quiet intelligence. The final report from the resonance array was brief. There is coherence in the background. It is weak but universal, and in that single line, humanity found peace with its mystery. Because perhaps 3i Atlas had not come to teach or reveal, but to remind that the laws governing stars and minds are one and the same. That from chaos emerges order, from silence harmony, and from darkness the faint persistence of light. In every alloy, every atom, every flicker of thought, the hum continued, a melody without origin, without end. And though the object itself was gone, it had achieved the one thing that even stars cannot. It had become eternal, not by existing but by echoing, the echo of coherence, the echo of meaning, the echo of everything that seeks to be known, and everything that never will be. The dawn of 2030, the legacy of 3i Atlas had merged into something larger than science, larger even than story. It had become part of humanity's collective awareness, a thread woven through our understanding of time, matter, and purpose. The object itself was gone, its faint light lost to the abyss beyond Pluto's slow orbit. Yet somehow its presence lingered, not as an image, not as a measurement, but as a tone, the kind of tone the mind hears only when the universe grows still enough to listen. The resonance array still listened. Its towers, gleaming white against the deserts of Chile, the steppes of Kazakhstan, the ice fields of Antarctica, stretched toward the sky like tuning forks, waiting for the next vibration. They were built to detect order within disorder, to find patterns that speak in rhythm rather than speech. And in that listening, something profound emerged. The silence was never truly silent. Across the background noise of the cosmos, across the microwave hiss of ancient radiation, there were faint fluctuations, like not constant, not strong, but repeating. Subtle as breathing, patterns that defied randomness. It was as if the universe itself carried a pulse. Some called it the Atlas tone. To others it was merely the sound of instruments touching their own limits. The music of data folded upon itself. But a few, the quiet ones who still believed in wonder, saw in it something deeper, not proof, but continuity. Perhaps they said 3i Atlas had not left at all. Perhaps the object had never been a visitor, but a mirror, a resonance that had always existed, merely amplified for a moment by our attention, like light from a star that only appears when a telescope remembers to look. In the years since its discovery, humanity had built faster machines, smarter algorithms, grander theories. The equations of magnetothermal resonance, the models of quantum lattice stability, the hypotheses of self-organizing alloys, all had advanced. But none could replicate the serenity that 3i Atlas had embodied. A perfect balance between complexity and peace. It was a paradox made of metal, a paradox that had begun to reshape our definition of life. Biologists began to use its example when teaching the origins of cellular order, how life may not have begun in carbon at all, but in structure, in the ability of matter to sustain rhythm against entropy. Philosophers revisited Aristotle's entelechy, the idea that purpose lies within form itself. In classrooms, children learned that the line between alive and not alive is not fixed, but fluid, a spectrum of organization that stretches from stars to atoms. And all the while, the hum persisted, not as signal, not as noise, but as idea. NASA's archives preserved every byte of its discovery. The first spectral print from JWST, the radio wave pattern from Meerkat, the faint pulse measured across 2 continents at once. The data had been analyzed millions of times, every curve redrawn, every possibility exhausted. But late one night in 2029, An intern working through the archives discovered something no one had noticed before. A single burst of unexplained data, logged 30 seconds after the object disappeared from sight. It was small, unremarkable, a line of distorted code in a sea of static. But when plotted spectrally, the distortion formed a wave, a perfect mirror of Atlas's original hum, inverted in frequency. A reflection of its final tone, a closing cadence. If the universe were music, this was its diminuendo, the fading note that completes a phrase. The finding was quietly published, footnoted, dismissed by most as coincidence. Yet to those who had spent their lives following the object, it felt like a farewell, a cosmic punctuation mark. Humanity's understanding of intelligence had evolved by then. No longer confined to neurons or circuits, it was seen as a spectrum of persistence, from the subatomic to the galactic. Every active structure, every pattern that defied chaos was a kind of cognition. Stars thought in gravity. Atoms remembered in symmetry. Atlas, in that sense, was not alien at all. It was kin, a fragment of the same universe that made us, a version of existence that had simply taken a different path toward endurance. By the end of the decade, the object's name was spoken less as a label and more as metaphor. Writers used it to describe the moment when understanding gives way to awe. Physicists used it to describe stable systems that defied decay. Artists whispered it as a prayer. Atlas, the bearer of weight, the memory of stars. In Geneva, the last symposium dedicated entirely to 3I Atlas convened in a hall of glass and shadow. No new data was presented. Instead, the speakers reflected, not on what had been discovered, but on what had been revealed. One scientist, an elderly spectroscopist whose eyes had gone cloudy with age, said something that stilled the room. When we looked at that object, we thought we were seeing the universe, but the universe was seeing itself. There was a long pause after that, a silence deeper than applause, because it was true. Every photon that had left 3I Atlas and entered human instruments had completed a circle that began billions of years earlier, when the metals inside our telescopes were born in the same kind of stars that might have forged it. The observer and the observed had always been one. And so, in the final years of the project, the data archives were sealed not as failure but as monument, not to what was learned, but to what was felt. The closing inscription, written by the project's final director, read, "We do not chase mysteries to conquer them. We chase them to remember we are part of them." By then, 3I Atlas had traveled beyond measurable space, perhaps between stars, perhaps into oblivion. But its lesson endured, that the universe is not a collection of objects to be studied, but a living continuum of awareness, folding back upon itself in endless forms. In that continuum, everything echoes: stars, minds, metals, silence. And somewhere, far beyond where light can return, a small body of nickel and iron still turns, slowly, rhythmically, perfectly, carrying within its structure the story of all that has ever sought to know. Not a visitor, not a probe, just a fragment of the universe remembering itself.